Whenever we're thinking about angles, we should probably think about sine and cosine. And whenever we're thinking about sine and cosine, we should look at a circle. You could look at the unit circle, but I'm just going to look at a circle with radius r just to keep this a little bit more general. So if you write this as vectors, you can do this with complex numbers, by the way. I might be doing that. I'll do another video going over that. But the horizontal component will be r cos t, and the vertical component is r sine t. And you can see that here. I figured that out from the diagram. You can also factor out the r if you want. And then it would basically just look like r times a point on the unit circle, which is cos ti plus sine tj. So now when we're thinking about physics and calculus, let's differentiate this with respect to the angle. And in this case, the angle is what I'm calling t. And the reason for that is basically what you can think about it as is that every 1 unit of time that passes, the angle increases by 1 unit. So, and basically we're trying to figure out what is that unit in question. So the angle unit is increasing as time increases. So that's the reason why I've called that t, and differentiating with respect to t is kind of like getting a velocity. So this will be like a velocity vector. And then the way we can differentiate this is just differentiate each part individually. So you can see that r cos t, that'll become minus r sine t in the I direction, and we'll have plus r cos t in the j direction. And you can factor out an r if you want, and you'll have minus sine t in the I direction plus cos t in the j direction. Now you can use a dot product calculation to figure out that this is perpendicular to the displacement vector, and that should make sense because we're moving along the circle, so the direction we're moving is along the circle. So what helps now is we can look at the magnitude of this vector, and what you might notice is that the magnitude of this vector is the same as the magnitude of this vector, and you can obviously do that. I'll show how to do it now. So we get the magnitude of the velocity squared. Well, that'll be equal to minus r sine t squared plus r cos t squared. And that's basically just Pythagoras' theorem. So if we want to find the hypotenuse, we do the horizontal side squared plus the vertical side squared, and that'll give us the hypotenuse squared. And the absolute value of velocity is what we call speed. So that's the same as speed squared. So the speed will be equal to, so this will be r squared sine squared t plus r squared cos squared t. And if you factor out the r squared, sine squared plus cos squared, so sine squared t plus cos squared t, that's always equal to 1. So this part here is always equal to 1. So the speed, sorry, this should be squared, is just equal to r. So the speed is equal to r. And the unit for speed is obviously we have kind of like distance over time, right? Over time. Cool. So when the time is equal to 1, well then the distance traveled, the distance is equal to 1 radius. When the time is equal to 2, the distance traveled will be equal to 2 times the radius, because if this is 2 down here, multiply it up and we get 2 times the radius. So notice, as t increases, if t changes by 1, so if the angle changes by 1, we move 1 radius along the circle. So basically, we need to check how many radii have we moved along the circle. So if you think about the ratio of a radius to the circle's circumference, that's kind of where the notion of radians come from. So a question we might ask ourselves is, well, how much time will have to pass for us to get to this point here? And we can figure that out quite easily. So in order to get to that point, we'd have to travel this much of the circle, and this is a semicircle. So the pink part, the pink, will be equal to, so 2 pi r is a full circle, but then we only want to go around half the circle, so that's divided by 2. So the distance around the circle that we travel is we travel pi radii along the circle. And if we wanted to do the whole circle to go all the way around, well then in that case, the pink part would be equal to 2 pi r, because the entire circumference of the circle is 2 pi r, so we've traveled 2 pi radii along the circle. So this is where the notion of using radians to measure an angle kind of comes in useful. And to show this, let's generalize it. So we know that our unit of time is basically how many radii we've gone around the circle. So if we want to figure out what is the time, well, we have to figure out how much have we traveled. So I suppose we call it the perimeter, or how much have we traveled, the distance we've traveled. And then we divide that by the radius. So we basically check how many radii can I fit inside of the distance that we've traveled. So for example, when we traveled the semicircle, well then the distance we traveled was pi times r. So in this case, you'd have pi r divided by r, and that gives us pi. And this is exactly how we define a radian. So you can see when we're using calculus and physics and looking at velocities and stuff, the way that we have to define t is exactly how we define a radian. And basically the whole reason for it, if you wanted to summarize it quickly, it's because when you use a vector to describe a point on the circle, the length of that vector is the radius of the circle. So whenever we look at velocity, it's going to have the same magnitude, and that's just because when you're differentiating sine and cosine, you just get more sines and cosines, so the magnitude didn't change. So that means we end up just counting how many radii we went around the circle, and that's exactly what radians are. It's counting how many radii we've gone around the circle.